Hello YouTube and welcome to yet another full stack to do app. In this tutorial we'll be using a mono repo setup that has a database REST API server connecting to a client package that is then embedded in a web app that will be on your browser. And it will be using TypeScript throughout, so a single language to develop our full stack app. So the plan for this tutorial is to use a Loki.js as our database in an in-memory database, and we'll have our users and to-dos collections to manage our users, of course, and to also manage our lists of to-dos. This will then be hooked up to our REST API, which will be using the HyperExpress package. It's very fast and is similar in the principles to Express. So if you've used express.js at all, then you'll be right at home with HyperExpress. We'll also be using JsonWebTokens for the authentication and authorization of commands or requests being made by end users through the client. That will then lead us to the client package, which will be using the native fetch commands in Node and the browser, so we can have a client that we can use both on the browser and in Node, so we can have command line applications or GUI applications built for specific desktops or OSs, but as well as browser applications. And then we'll connect and use that client in our web app, which will be created using React and Bootstrap. And then throughout this, we'll be using TypeScript, so that will help us with our syntax and making sure that we expect the right objects to be passed through our functions. Typebox for verifying and validating the objects being passed through our functions. We'll be using Prettier to keep our code nice and clean and in the right formats and structures, just for styling wise and ease of reading. We'll be using Node.js's inbuilt testing library, PNPM for the package and monorepo workspace management. So that'll be installing our packages and making sure that the packages are stored appropriately for each of our packages that we're developing in this monorepo. And then at the end, once we've built the entire application out, we'll be looking at how we can deploy that through Docker. And then that could be on AWS or like Azure, Google, Oracle service. So I said about the multiple packages. So database and REST API are going to be rolled up into package 1. The client is going to be rolled up into package 2. And the web app is our package 3. And they are going to be depending on one another, so we're going to show how you can import local packages within the respective packages in the mono repo. So why I like to use this setup, it's really good I find for research and development and prototyping. You're not dependent on any large services or having to do single sign-on procedures. So it's really good to get some minimal viable products. You can host it on a single, like EC2 instance, for example. So it's really good, easy to boot up and run and then shut back down. The modular layout as well, we've had good success in the past where we can then build it out into full industrial size scale applications. So for example, taking this database, in-memory database, and then changing it out for a Mongo database without having to then change any of the REST API client or web app backend. There's just a bit of additional gluing just to change the commands between MongoDB and Loki.js, for example. So it's very kind of progressive in that we can build out that. The fact that we've got a client as well that does all the interactions with our REST API, we can then have multiple front ends. So we can have a web app for maybe development purposes and trialing out new options and styles. And then we've actually got the commercial web app that's being used by clients, both interacting with the client and the database in the same way. So before we get into the today's tutorial and demo itself, we will do just a couple of notes on my development environment. So I'm using Windows Subsystem for Linux, and it's the default Ubuntu install. So if you Google WSL and install that, then you'll have the same environment that I'm working in. And if you're on Macs or Linux itself, then all the commands that we'll be using in the terminal will be familiar to you as well. So it's we can use it across all OSs. I've installed Node Version Manager, and I've set that to Node version 20, the latest LTS when I've made this tutorial. And so it's really good for managing multiple versions of Node on your platform. So if you're coding in version 16 for a colleague, then you can switch between the two and not have them interfere with one another. I'm also using VS Code with the Prettier plugin, helping with the styling. So when I control save, I've got format and organize imports on save happening. So you might see my code jumble around automatically based on the settings for the Prettier plugin. I'm using the JetBrains mono font with font ligatures, so you might see some funky fonts if you've never seen font ligatures before, where they adjoin characters just for help with code readability. And I'm using the Tomorrow Night Blue theme for the VS Code. So in today's tutorial, I guess probably the next 40 so minutes, maybe 30 minutes, we'll see how we go. We're going to just talk about initializing the project and then booting up and shutting down the server and REST API. We're not going to be adding any collections just yet, or any pinging any server requests just yet. Just getting it to boot up and shut down, and then in the following tutorial we'll start adding that functionality. So just before I go into the code itself, I just thought, just show you, like you say, Visual Studio Code. If you Google that, VS Code, it'll be taken to this website. You can easily then download it for your platform. It's across all the major OSs. And then Node Version Manager, if you Google NVM, you'll find this GitHub page, and this is the Node Version Manager that I've been using to manage our node programs. Again, it's a simple command line install, and then you're able to then switch out and into the node versions you need for whatever projects you're working on. So yeah, before we get started, so what I've done is already booted up my WSL, and I'm going to then start creating our first folder, which is going to be our root for this project. What to do, we'll enter that folder, and then of course boot up code. So that should boot it up on my other screen. I'll bring it across. Here we are. There we go. So yeah, we've just got an empty folder ready to start our project. And the first thing we need to do really is also just start with a few initialization steps to describe what the project is and what we're developing. So in here, first of all, we might want to git init. So we're going to initialize it as a Git repository to save our code, back it up, manage our version control. Alongside that, then you typically write a git ignore file. So there we create a git ignore file, and we'll be adding a few features as we go along. The first one we'll be seeing today will be node modules, which is where when we install packages, they get installed within node modules. So we don't want to commit those to our repo, so we'll put that in the git ignore file, so Git understands not to include those. We will also want to do is then init the package itself, our mono repo, so pnpm init. And something I probably should also say is that yes, once I've installed Node, I've installed pnpm globally, which is a case of doing npm install -g pnpm, and then now I'm using it throughout all my applications. Okay, so if you say there's a warning when you run pnpm, it's not installed globally on your system. Anyway, so we've installed, we've created our package.json, and a couple of things I like to do when I've created that is to first at the top level is top entry, put $schema, and then look for package JSON. So this is also completing thanks to VS Code, and the schema keyword there is now going and finding that schema written in that URL address, and what it's going to do, VS Code magically is going to be checking the structure of our package.json, making sure that we don't add any keys that it doesn't conform to. When we add entries as well to those keys, the values conform to whatever specification. So whether it's a string, it's a number, a string of a certain format. So one other aspect we want to add is, and here's an example, we want to say what type of package it is. So historically, you might be familiar with CommonJS. but now more recently we are using the ES6 syntax, and to differentiate them we call it module. So we want to make sure that VS Code and the runtime knows that it's expecting a module for our packages. So that's all we necessarily need to do at the stage for this top level package.json. The next bit we would like to do is, I've got my example here. I've got a couple of examples. I will want to add some prettier config. So styling is entirely individual and subjective, so how you want to style your code is entirely up to you. And fortunately, prettier ignore. Prettier has a couple of files that you can create to help set up styling of your choice. So I'll create these. And yes, like I say, I'm going to push this repo up at the end of each of the tutorials. So and then put that commit version, that link into the comments, so you'll be able to see what this repo looked like at the end of this tutorial. So you can then just grab these files rather than having to write them out potentially all manually yourself. So for the prettier RC file, we want to set some the schema, because I believe it has a schema online. There it is. So again, that just helps us as we're writing to make sure that we write the appropriate keywords. I tend to have semicolons at the end of my lines as turn to false. Use tabs as true. Just because some of my colleagues like to have spacing of 3, 4, 2, and tabs allow us to configure that per instance, per our own personal preferences. We will do single quotes. I'll put that as false. I tend to use double quotes, or I like double quotes in my code. And print width, again, it's how aligned and where does the line breaks within our code. And we'll try and fit within 80, and that is the default. So we can save that. And I've also put a prettier ignore a folder, a bit like git ignore. There are some files and folders that we don't need prettier to look for files to clean up. They're either managed by other processes or they're temporary files, so they can be readily deleted and recreated. So not worth spending the time and effort formatting them. So I'm going to put in two ones in there for what you'll see. So you'll see this in a moment. PMPM lock. It's what PMPM uses to make sure we're using the right versions across when you pull the code and use it. We're using the exact right same versions when you do PMPM install. And then we're going to have a few temporary folders for storing temporary files when we'd be running, like the database in development mode would put that in the temporary folder. So I'm just going to say ignore those as well, so we don't need you to format any files within those folders. So that's that one all done. And it also automatically, we can also, if we want to, node modules actually, why not? But it automatically normally ignores node modules as it's a recognized folder that we don't need to format. So we've got, we've initialized Git, we've initialized the package, we've set up how we want our code to look when we're styling it. The last bit is the TypeScript configuration. So how we want TypeScript, so how strict we want to be when it's analyzing our code and raising warnings to us. So that is produced using a tsconfig file, and we'll have a few of these again. A top level tsconfig file, and this will have all the rules that we want all our packages to conform to, and then we'll have some specific rules for the different packages, because for example the server is going to be running on Node whilst the web app is going to be run in the browser, and we want it to recognize the difference of the runtimes and the features that are within those. So and for this one, just to save and for expediency, I am just going to copy and paste that across from my example. Not necessarily because it's not often that you're going to be changing too many of these options. There's a whole raft of examples out. tsconfig, if you just do tsconfig Google, there's a whole GitHub repo of examples of how they set up. You can even use those, just copy and paste those or reference those in your code. So just a couple of, I guess, just to highlight a couple of these ISOs. Basically what we're trying to look out for is it's going to try and recognize unreachable code and warn us about that. It's going to warn us for variables not being used, that we're not returning functions properly, and any kind of unused parameters as well throughout the projects. So those are some of those bits. We've also got actually the no emit. So we're going to use TypeScript here purely to check the code. We're not going to use it to compile it into a JavaScript runtime. We're going to actually run the code directly as a TypeScript file using a package called TSX. So you'll see that in just a moment. So now that's tsconfig all set up and described, hopefully. We can now start thinking about actually building out our workspace and setting up the packages. So what we need there is a pnpm workspace .yaml file. There we go. And in that we are going to tell, this is just to tell pnpm the workspace where our packages are going to exist within our, oops, not bad typing this morning, where they're going to exist within our mono repo. So we just, in here we're going to say packages, and so this is going to be our list of packages, and the first one we're going to do is server, and we're going to put it in the server folder. So now, by just having that file within it, pnpm will recognize that we are going to be working as a workspace mono repo repository. So now I've just created that folder, and we're pretty set to go about to get into start building out that server. But there's a couple of packages that we might want to install at the top level. So I'll just clear that screen there. I can maybe increase this size a little bit. Oops. I can grab the top. There we go. That's better. So what we want to do is install a couple of packages at the top level, because we're going to use them throughout. So you'll have packages at the top level if you want to use them throughout throughout your packages. Then have package specific packages installed, so they don't conflict with one another. To do that, we'll do pnpm space w add. So the -w, sorry, is workspace, the top level workspace, and we're going to add TypeScript. And actually, we're going to add these as dev development to these. So that's oops, here as well. That's D, capital D, as development dependencies, TypeScript and prettier. Okay, because we fundamentally don't need TypeScript and bridges. We won't need them to run the code. They're there for checking and for formatting. So just enter there. Hopefully, because I've got them cached, it won't take too long to install. There we go. Now we've installed those, and you probably see on the left there is the node modules file is being created. So that's where they're going to be stored. The different versions that we've installed. The pnpm lock file has been created. And in our package.json, it started listing our dev dependencies. So like I say, when I do control save, it is going to be saving those files. It's going to be formatting automatically, but it's also good to have a top level script to say, right, format my files and run through the entire code base just in test to check catch any ones that might have been missed. So to do that, we do that through scripts. The top level, we want to create a script called format, and I'm just overwriting this test one, and we're going to call it prettier. So we're going to call the prettier function. We're going to say write, because we want it to overwrite our files with the new organized neat version, and we're going to put the dot i.e. look throughout this project, throughout this repo. So if I've written that correctly, I've got to do pm format, or run format, sorry. And I need to also, remind myself, put the space -w again. We're going to run a command that is in the workspace. And off it goes. There we go. So it's found pretty.json's changed, and pm workspace, it's updated, and tsconfig. So it's looked and identified those to format those for us. There we go. So like I say, often you might not use that. You might put that in a GitHub action. So when you push the code up, you might have GitHub automatically just check that, and before it gets committed, do those formatting. Or just before you do a commit, it might be worthwhile just pushing that format button just to check all the code's all neatly arranged before committing to your repo. So with those all done, we are now ready to start our server package. To do that, we can go into the server. So I'm just, and again, we start off as if this was like a new repository, or a separate package, as it is. In it, the package.json file. So now we've got the server package.json to recognize it as an independent package. As before, I will just put schema. So we've always got that to help us out, and I will also put type as module to recognize that this is going to be our module. And bring up, that's it. So I think, and this where we need now the other tsconfig JSON, because we want to just tell TypeScript that this package is going to be running in Node. So what we want to do is, as always, that's it, $sign schema, find the tsconfig schema. We're going to use the extends key value word, and we're going to say it's going to extend our top level. So we're going to basically take all the rules that we've set in our top level, and we're going to then add a few additional ones. So for our compiler options, we're going to just tell TypeScript that this is going to be running on the most recent up-to-date module. So I note next to say it's going to be running on Node.js rather than in the browser. So now we've got everything configured to start actually hopefully writing. Maybe we'll do just a console log to the window just to start running the server. So to do that, we'll start creating a couple of packages. We'll install a couple of packages that we'll be using, and these are let's do our dev dependencies first. So now we need to do the -f. So this is going to filter, and we want to filter for server. So we want to find our server package, and we're going to add, and we're also going to do -d, because we want to do it's a development dependency at types/node. So we recognize we're in Node. We just want to have the types for Node. So when we start writing nodes, it'll automatically help us and assist. So importing things like fs for reading files into our program. We also want to then run some and add some packages that are key to running our server. They are Sinclair/typebox. They are HyperExpress and Loki.js. Okay, now it's just checking the cache that I've got on the program, and there we go, and it's just installed those packages for us. So if we have a look in our folder tree just now, we've got our node modules folder, and if we look in package.json, we've got our types node, and then we've got Typebox, HyperExpress, and Loki.js installed. The one other one that I just missed off was at types Loki.js. So we have the typings for Loki. They're in a separate package, and I'll put that as a dev dependency. Again, typically all your typings, if they don't already come with the package, you might want to install as a dev dependency, as they're not, specifically required. And as one and then one more, just recognizing it, TSX. And that is going to be how we're going to run our program without having to compile it into JavaScript itself. We're just going to run it straight as a TypeScript file. So that should be all we need to run run the server. So to start this, we want to say we want to create our index.ts file. That's it. I'm going to just put it at the top level here. You could embed this within a source folder and start building out your tree. I think we're not going to go so complex here, so I think just keeping the index at the top level. We'll have a couple more folders as we go. It's fine for here for now. In the package.js, just double check we want to finish that to .ts there to link, so it knows our main entry point to the server is index.ts. And let's say for now, let's just configure our just hello world kind of program. So we just want to configure how we're going to run this program. And to do that, we're going to have we'll just do a console log hello world there, and we're going to now create a start command in our scripts, and we are going to put there. So here we're just going to do tsx index.ts. So if we double check now, we should be able to say pm -f equals server run start. There we go, and it's recognized that run the server workspace, run the command run.tsx. We can make that even a little bit easier as well. If we want to run it at the top level, we can go to package.json at the top level. We could do start server, and we can have here pm then have equals server. We just copy that command in effectively, and start. So let's say we could do a similar command at the top, run start server. There we go, and then there we go. So it's done, and it's gone and run tsx index.ts and outputted hello world. So now we've got it all joined up, so we can boot and run the server from different points in our project. Okay, so we can close those bits off. Let's get it cleaned up, and now actually let's start doing some of the coding. So again, like I said, today we're going to get to the stage where we want to initialize our instance. So we're going to boot up the Loki.js database, and we are going to initialize this REST API server. To do this, normally the first step actually we want to is have a globals kind of config operation. So we want to import some global config, such as where is the database going to be stored for persistence, and we will have some things like JsonWebToken secrets and stuff like that added into that. To do that, we are going to create a config.sample.json, and this is what we're going to commit to our Git repo. And I'm going to put in here for now, because the only first one we want is db file. We're just going to keep it blank for now. And then we're going to actually then recreate that as config.json file, and we can then do exactly the same. And we're going to say the temp folder.json. So, and I'm going to go and create that .temp folder now in the server. So we're going to have a temporary folder just for storing these bits whilst we're developing. The reason why I do a config.json and a config.sample.json is that depending on how you want to run this code on your platform, you might want to put things in different folders, and we don't want to put secrets on the web. So we want to make sure that actually the config.json file is ignored when we commit our code to Git, and but we'll have the sample as a reference point of what does that config file require, and just leave it blank. So with that, we then can then say, actually, we want to then import some global variables. Okay, and we're going to actually get it just to, our code to look for that config.json file and import it and update our variables. So to do this, we're going to create a globals.ts file. And just close those. Okay, what's this file? And now what I'm going to do is create a type and describe what that global variable is going to look like. And we're going to use typebox here, so we can use the verification when we import that config.json file to say whether that config.json file conforms to the type global variables, global vars we're going to call it. So we're going to import some functions from typebox. Let's Sinclair. Oops, need to put those. There we go. It's already trying to recognise it. And this is the beauty of the IntelliSense and TypeScript and built into VS Code, that it's got some very good type hinting as we code. And we're going to have a variable called global vars that we're going to use throughout to access and use our objects. And this is a typebox object, and this is where we describe what we expect the global vars to consist of. So as I'm writing here, I'm saying db file, we expect to have a db file keyword, and we're going to expect it to be of type string. We have additional properties set to false, so if there was additional keys within that object, it would raise an error for us. And we're going to then automatically export the type global vars based on that object, that typebox object. So it's saying this is creating the and we just need to re-import it because my prettier automatically removes unused imports. So that's then creating this type vars, and I've got a little error there because it needs to be an arrow. And now we've created that in our globals, we're going to be using it itself, and we're going to say, actually, let's go and define now. Export that globals. So this is going to be our global, we'll call global vars, and it's going to be of type global vars, the thing that we just defined above. We're going to just have it as so when I start writing db file, it's telling me that should exist. And I'm just going to keep it empty for now. So the default for this when the package runs is just to have empty global vars. And now what we want to do is check if the config.file exists. So I'm going to go if not exists sync. So that's already imported, as you see at the top, a Node.js function fs exists sync. It's just going to check for a file, and we're going to tell it to check for config.json. And if there is no config.json, we're going to raise an error. Could not find config.json. And we're going to just then exit the process. So it will prevent the code from continue running. If it passes that check, then the code will continue running. And we're going to pass the read file sync. We're going to pass that file. So we're going to read in the file data as a, and we're going to expect that it should be passable as a JSON object. So this is just saying read file config.json. We're going to make it into a string that then JSON will pass into a JSON object. We can then use again our types that we've defined above. We are going to use value dot from type box, and we're going to say check whether we give it the type that we need to check against. We're going to say global vars. We want data to look like or conform to the specification of global vars. If it doesn't, that's what the exclamation mark highlights. We are going to then write out the errors for global vars. And then we're going to exit there. So we're going to say, yeah, if it doesn't conform, there must have been some issues. We'll get typebox to then tell us what those errors are and exit the program once more. If all is well, we'll set our global vars to our data. So then we've got where we want to store the database. Right, now we've imported some global variables. We are actually now ready to start booting up the instance of our database and initializing the REST API. So what we want to do is first do a check whether this file is being run as main, as the main file, the main entry point. To do this, we are going to do a if import.meta .url. So this is just getting the file name. If it starts with file, we're going to then grab the path, we'll call it module path, equals file to URL, and that's another inbuilt function for node, meta.url. And now we want to just check that this process is this file, and if so, we are running the we're going to run the server. So we go, we're running as main, so we're going to go running from server /index.ts, just to highlight what's happening. So when you see the code run, you go, oh yeah, that's where I'm passing through. And we want to now then initialize the function. So we'll delete it. So no. And this is where we're going to init the server. So let's create a function called init server. And throughout this, I'm using different names here for like init server. They're all generic. They could be whatever you might want to name it. So yeah, feel free to change those that suit your what makes most sense to you. So we're going to init server. It's already doing a wiggle because it's saying, hey, it's declared but never used. So that's those kind of TypeScript warnings that I said before, because we've set we don't want any unused functions. So let's just put it at the top. There we go. So we've got init server, and now we can db new Loki globals. Yeah, we need to import globals. Oh, global vars, sorry, global vars, like that. Yep. Dot db file. So we want to. So what we're doing now is initializing the database. Loki. We're going to give it the file where we want to store the database. We're going to say auto load true. We want to load that file if it's been persisted, and we're going to have a callback, and we'll come to that and So once the database is loaded, we then want to then boot up REST API. There's no point booting the REST API unless the database is loaded. So we'll then create a function within init server called init service, or init. Let's do REST API, and we will then place that in the callback. So we're going to go, once you've booted up, please initialize the REST API. And we're going to have autosave as true. And we're going to set the autosave interval to 4000. That was also based on the documentation in Loki.js. Entirely up to you what you would like as your autosave interval, and whether you want to autosave or save as and when actions are taken on the database. At this point, I'll just put a couple of comments. So this is where we'll take off from the next tutorial. Next stage is we'll initialize the users collection here. And now what we'll do here is create the REST API. Alright. To do that, we want to use HyperExpress. So if I start writing const app, we're going to call it an app. And we're going to go on new server. And here we've got some options of where server is come. We've got servers in some of the default node packages. And there's the one with HyperExpress. We'll just click enter, it'll automatically import it at the top level, and we've initialized the REST server there. We'll also provide a port, and we're just going to give it port 3000 for now. Again, entirely up to you what you might want to set that to. And then we can say listen to 3000. Oh, so listen to port. And when you've booted up, you can tell us. So say console log server started on port p. Let's do local host $sign port. So it's going to insert our number into that link there, or into that URL. And we're going to then catch, we'll put a catch function to say, okay, if there's an error that occurs, then we'll describe that error as any, it could be of any structure. We are going to say console log failed to start console error, log the error, sorry, there we go. And we can do a process.exit here, because there's not worth continuing if our REST APIs had an issue. And there's one last little bit then. So this is booting up the service. So we'll start with initializing the database. Once that is happy, it will call init REST API, which will boot up our API endpoint. What we'd like to do finally would be then to do process.on SIG instance. We want to be able to close the program gracefully. Key thing is here to make sure that the database closes and flushes any data to the file, and doesn't close where it's half written the file, or any of those potential issues. So the main thing here we want to say, so SIG init ent is like, say, if you do a Control-C and the program, you want to close the program, we'll just say console log closing the database, and then we can put db.close. And because, so there's the reason why we put the function here and the process on SIG init within the function is then it's got access to the database variable at the top here, so we can use it within the functions. So then we do console.log database closed, and we can do process.exit. And I believe that will be enough to for us to say, yep, here's the service booted up, we shut it down, and then we're ready to the next stage. So if I then just run start server, oh, right, there's a, oh, Loki is not defined. Ah, it hasn't been imported at the top level though. So just make sure that that's imported. Let's just double check the import statement. Yeah, the Loki's at default, so that's, and I'll just do loki.js. There we go. So we've imported Loki from that top level. Now we're going to run the top level workspace function, and there we go. That's it. So we are ready. We are now running a server at localhost 3000. The database was loaded up, and it's all running. And then if we Control C, we should have the commands closing the database close. So it's command to that. And that's where we are. So that's, I think, the end of like the first stage. That's it. We have created a workspace. We've set up all our config. We have then loaded the server. We've booted up the database and initialized the REST API, and we've bound to shut it down nice and neatly, making sure that the database closes appropriately. So yeah, thank you very much for listening, and look forward to seeing you in the next tutorial. Bye bye.